Hello everyone, this is the cloud bursting demo video. Cloud bursting is a configuration which is set up between the on-premise clusters and public clouds to deal with peaks in IT demand. If it reaches 100% of on-premise cluster resource capacity, it will scale the workloads to the public cloud. Just like this picture shows, the pods are scaled with workload increasing, and once it reaches 100% of on-premise cluster resources capacity, the pod will be scaled to the cloud. In today's demo, we will scale the pod following the logic like this. We will start from running a new pod on-prem, and once the memory utilization of the pod reaches 70%, we will reach another new pod on-prem. And once there is insufficient memory resources on the on-prem to start the new pod, the pod will be pending status, and we will scale this pod to the cloud. So, so there are kind of two policies in the logic. The first one is that once the memory utilization of the pod reaches 70% on-prem, we will scale a new pod on-prem. And the second policy is that once there is insufficient memory resources on-prem and the pod status became pending, so we will scale the pod to the Azure cloud. And after the pod is scaled to Azure, we run the pod with confidential containers. This picture shows the confidential containers in Azure and trusted on-prem. You can see we set up the VPN between the on-prem cluster and Azure. Also, when with the confidential containers, when the workload starts running, we prepared a HTTP web application for the demo. This file is encrypted, so it needs to get a key, decryption key. It needs to get a decryption key to decrypt the file before serving. So while the key is stored in the trusted KBS secret, so it needs to retrieve this key. The process looks like this. The container requests the key to the CDH, and the CDH requests the key to the trusted KBS. However, the KBS will only release this key after it gets the TE attestation token. So the attestation agent, it sends the evidence from this TEE to the KBS, and the KBS sends the attestation request with the evidence to the attestation service. After the attestation service verifies the evidence, it will send the attestation token to the KBS. Now the KBS gets the attestation token, and it will release the key to the CDH. Now the container could get this key, and the encrypted web application file could be decrypted successfully and could serve. Okay, next I will show the operators we installed for the demo. Custom metrics autoscaler. A simple introduction about it. It's based on the Kubernetes event-driven autoscaler, KDA, and it allows automatically increase or decrease the number of pods for a deployment. Suitable set customer resource or job using additional metrics sources other than pod metrics. Second operator is Openshift Sandboxed Containers. We enable the peer pods and confidential. The other operator is confidential compute attestation. We use this operator for the confidential containers attestation workflow. Okay, next I will show the YAML files we used for creating the deployments and the data policy. First, let's check the nodes. This is a bare metal server, so we deployed the OCP on-prem cluster. Next, let's see this is a YAML file. Let's say the on-prem deployment. We name it as on-prem deployment, and replicas is one. So we start from running one pod on-prem, and the deployment is labeled with app, my web app, and it's using the image like this. So below are the configurations. I'm not going to explain each detail. Let's create on-prem deployment. The second is cloud deployment. The name is cloud deployment. Replicas is 0, and the label is same with on-prem deployment, my web app. And about the annotations, as a confidential containers doesn't allow user to log in or get the log of the container. So just to be able to, for the debug purpose, and we, as in the demo, in the next steps of the demo, we will show the trusty logs and the container logs. So we add this annotation just for the debug purpose. Um, and also you can see we set the runtime class name with kata remote. For the on-prem deployment, it's with default runtime class because we assume that the on-prem cluster is deployed in a trusted environment. And about the container image, it's use the same one with the on-prem deployment. So this is a cloud deployment, but with 0 replicas. So there's actually no pod is running with in the cloud. And we also define a service to expose the network application, which is running as both on-prem pods and cloud pods, which are labeled as my web app. And we also define a route to host the application at a public URL. Now we create 2 deployments and service and ready. Next, let's say the 2 data policies. Let's start from the first one, memory scalar object. The purpose of this policy is after the memory utilization reaches 70%, it will scale the on-prem deployment. The second policy is based on the pod status. If there is a pending pod status and the pod name is on-prem deployment, it will scale the cloud deployment. Next, I will run the workloads, and you will see the whole process of the pod scaling. Before start running the workloads, I would introduce the 3 windows. This one will run the workloads in the terminal here, and this page it shows the pod, and we will say the pod is scaled, so we can see all the pods here. And so at the beginning there is one pod on-prem is running, and this web page is Azure web page. This page shows the VMs. We currently there is no VM. It's running. And after the pod is scaled to cloud, we will see one VM here. Okay, next let's start the workload. Let me give an introduction about the workload. In the image, it will start a HTTP server, and when we send a HTTP request, it will return the name of the pod which is handling the request. And at the same time, the server will allocate some memory at each request to simulate a memory intensive workload. So you can say this is the this is a pod name, and it has handled 3 requests or 4 requests. And here is the pod name. It ends with V. So once the memory utilization of this pod reaches 70%, we will see a new pod on-prem will be scheduled. So let's wait a few seconds to say, yeah, now we can see it. We can see a new pod has been scheduled. It ends with 8. And now there are 2 containers handling the HTTP request. Um, after the memory utilization in both containers reaches 70%, we will have the third pod. We will see the third pod will be scheduled on-prem. Here now we can see that the third prem is scheduled. However, it's in pending status. Let's check why it's pending. Um, the pod unschedulable, the 0 nodes are available. This is because one insufficient memory. So as there's insufficient memory, it's pending status. Now we can see that a cloud deployment is scheduled. So a cloud deployment pod is running, and let's check the error page. Let's refresh this web page. Here we can see that pod name with pod name cloud deployment is running, and the size is standard DC2 ASV2. This is the SMP, so this is a confidential VM. So now the peer pod confidential VM is running in Azure, and the cloud deployment pod is in pod initializing phase. Here it's running status. So the cloud, the pod in the Azure cloud, this container is running. And let's check the request. Now we can see that the requests are handled by 3 containers. 2 are on-prem pod, and the third one is cloud pod. So they are handling the HTTP request. Next, I will show, yeah, this is the workload running. Let's stop it. The pod scale process has been finished. Now let's say I will share more logs about cloud deployment. Let's check the logs. You can see that the HTTP application is encrypted, and this is fetching the key from the trustee, from the workload k.bin, and it gets the key here, and now the file is decrypted successfully. So in the log, we can see that the initial HTTP application is encrypted, and it retrieves a key from the trustee, and then use this key to decrypt the file. And next I will share the trustee logs. Let's switch to trustee operator system, and let's say the KBS logs. Here we can see that we can see that it gets resource from the KBS default workload k.bin, and the resource access request passes policy check. So so the KBS released the key to release the key. Yeah, that's all. Thank you.